Very good morning, and today we will start the fundamentals and all level problems related to the topic limits and continuity. And uh, this is most important topic to learn calculus. The calculus or fundamentals limits and continuity. And we have to give more importance in learning limits and continuity. The limits and continuity some fundamental concept. Let us concentrate the fundamental concept. What are the limits theorem? If we take limit of algebraic sum of two different functions f of x and plus or minus g of x, the variable x approaches 0. Okay, so we can separate and find the limit. Limit x approaches 0 f of x, and we can separate the second one, but the same limit x approaches 0 alone. Our general case f approaches a also can be taken. In the place of 0 you can take a, x approaches a g of x. This is the first fundamental theorem. The limits of algebraic sum of two or many real functions and can be estimated as an algebraic sum of their individual limits. Okay, so this can be taken as 1. Then second one, a limit x approaches a. Now product can be taken f of x and g of x. Remember student, this is not composition of two real function, product of two real function. So the multiplication operation connect two real functions f of x and g of x. And here a limit x approaches a f of x and limit x approaches a g of x. And third one, limit x approaches a quotient of real function. Limit x approaches a f of x divided by limit x approaches a g of x. Under the condition g of x not to be 0, otherwise the rational function will not be defined. Clear? But rational function, whenever we encountered a rational function, very careful. Let g of x denominator on the 0 ஆகக்கூடாது. And the condition we have to include. Otherwise in the question itself, no, the supportive domain would be given. Okay. The next one, limit x approaches a. In the place of g of x, we can take some alpha real number f of x. So if you apply the limit of alpha and limit of f of x, remember student, very important, the limit of any constant, the constant itself. ஏன்னா கான்ஸ்டன்ட்ல எந்த சேஞ்சஸும் இருக்காது. லிமிட்டை அப்ளை பண்ணும்போது இந்த கான்ஸ்டன்ட் வந்து இண்டிபெண்ட் ஆஃப் எனி லிமிட், எனி வேரியபிள். கான்ஸ்டன்ட்ங்கிறது இண்டிபெண்ட் ஆஃப் எனி வேரியபிள். அப்போ ஏதாவது ஒரு வேரியபிளில் சேஞ்சஸ் இருந்தால் அது எதை அஃபெக்ட் பண்ணாது? கான்ஸ்டண்ட்டை அஃபெக்ட் பண்ணாது. அதில் இங்கேயும் டைரெக்டாக செப்பரேட் பண்ணலாம். லிமிட் ஆஃப் ஆல்ஃபாங்கிறது ஆல்ஃபா இட் செல்ஃப், தென் லிமிட் x approaches a f of x. Okay, then we can take the limit on any composite function, composition of 1 or 2. So limit x approaches a f of g of x. F of g of x means the x approaches a. X is an independent variable of g, not f. For gங்கிற ஃபங்க்ஷனுக்கு தான் x வந்து இண்டிபெண்டன்ட் வேரியபிள். x எதோட இண்டிபெண்டன்ட் வேரியபிள் கிடையாது? f ஓட இண்டிபெண்டன்ட் வேரியபிள் கிடையாது. f ஓட இண்டிபெண்டன்ட் வேரியபிள் வந்து g of x. ஒரு ஃபங்க்ஷனே இண்டிபெண்டன்ட் வேரியபிளா ரியாக்ட் பண்ணுது. g of xங்கிறது என்டையர் g of x fங்கிற ஃபங்க்ஷனோட இண்டிபெண்டன்ட் வேரியபிள். பட் எக்ஸுங்கிறது ஜியோட இண்டிபெண்டன்ட் வேரியபிள். ஸோ ஓவராலாக லிமிட் எடுக்கும்போது ஒரு காம்போசிட் ஃபங்க்ஷன் எக்ஸுங்கிறது எந்த ஃபங்க்ஷனோட இண்டிபெண்டன்ட் வேரியபிளோ அந்த ஃபங்க்ஷன் மட்டும் லிமிட் அப்ளை பண்ணால் போதும். ஸோ இதை எப்படி பண்ணலாம்? எஃப் அது வித்தவுட் அஃபெக்டிங் எஃப். ஏன்னா அந்த லிமிட்டு டைரெக்டாக எதை அட்டாக் பண்ணோம்? ஜி ஆஃப் எக்ஸ் தான் அட்டாக் பண்ணோம். ஏன்னா எக்ஸுங்கிறது இண்டிபெண்டன்ட் வேரியபிள் ஆஃப் ஜி ஆஃப் எக்ஸ், நாட் எஃப். அதில் you can take the limit inside. Limit x approaches a g of x. Okay, this is a composition. Understood? So these are the fundamental theorem on limits based on எப்படி செப்பரேட் பண்றது, ப்ராடக்ட் மல்டிப்ளிகேஷன், quotient, scalar multiplication, composition. So all the five are very, very important. The name of the five result limits theorem. I hope you all understood this concept. Okay. So dear student, when நம்ம higher level limits and continuity discuss பண்ணும்போது sometimes என்ன ஆகும்னா the standard result apply பண்ணா result வராது. வரும், it will take more steps. அதை அவாய்ட் பண்ணுறதுக்கு சம்டைம் நம்ம எதை யூஸ் பண்ணோம்னா சீரீஸ், இன்ஃபைனைட் சீரீஸை யூஸ் பண்ணணும். அவர் லிமிட்ஸ் யூஸிங் இன்ஃபைனைட் சீரீஸ். Limits using infinite series. So what are the basic and familiar and useful and infinite series? Now we have to list out all this. So first e power x. E power x at infinite series form 1 plus x by 1 factorial plus x square by 2 factorial x cube by 3 factorial x power 4 by 4 factorial, keep going. This is infinite series. Okay, from this series alone we can derive the standard form. What is the standard form? Make note of it. E power x, the 1 is brought now to the left side, 1. The rest of the term x by 1 factorial, x square by 2 factorial going on. Then divided by x, also an infinite series. So e power x minus 1 by x or infinite series separate. First term 1 by 1 factorial. Second term x square into the x x by 2 factorial. Next x square by and 3 factorial, keep going. இப்போ e power xல x ஸ்கொயர்னா கீழே 2 ஃபேக்டோரியல், x power 3னா டினாமினேட்டரில் 3 ஃபேக்டோரியல். அந்த எக்ஸ்பானண்டே இங்கே ஃபேக்டோரியலாக மாறிடுச்சு. after rearranging that group term or after grouping e power x minus 1 by x ல first term 1 அப்புறம் next termல இருந்து எல்லாமே வேரியபிள் தான் in term of x. இப்போ இதில் நம்ம லிமிட் அப்ளை பண்ண what will happen, limit x approaches 0 e power x minus 1 by x is equal to 1 தான் வரும், ஏன்னா ரிமைனிங் டேர்ம்னா 0 ஆயிடும். ஓகே, இதுதான் அட்வான்டேஜ் ஆஃப் இந்த இன்ஃபைனைட் சீரீஸ். இந்த இன்ஃபைனைட் சீரீஸ்லேருந்து தான் இந்த ஃபார்முலா டெரிவேஷன் நமக்கு கிடைச்சிருக்கு. ஓகே, ஸோ திஸ் அட்வான்டேஜ் ஆஃப் லேர்னிங் infinite series of few real function. Second one, the infinite series form of log na ln da natural logarithm log of 1 plus x. So what is the expansion of log of 1 plus x? X minus x square by 2, okay, and plus x cube by 3, not factorial, minus x power 4 by 4 and plus x power 5 by 5. The pattern keep going on. Idanadu log of 1 plus x. The log of 1 plus x la, our right hand side we can take x as a common factor. So from this we can derive one more standard result, log of 1 plus x divided by x. And what is the first term on the right side? X becomes 1, x square becomes x cube becomes x square, and x power 4 becomes x cube, and x power 5 becomes x power 4. This pattern continue. When we take the limit x approaches 0, log of 1 plus x by x, the first term alone left, the remaining terms vanishes. So this is a derivation of another standard result, e power x minus 1 by x, and the limit of e power x minus 1 by x equal to 1 whenever x approaches 0. The limit of log of 1 plus x by x is 1 whenever x approaches 0. This is infinite series. If you want infinite series of and log of 1 minus x, log of 1 minus x, what to do? You can replace x by minus x. You can replace x by minus x. Log of 1 minus x. So x should be replaced by minus x, then minus of x plus x square by 2 plus x cube by 3 plus x power 4 by 4 plus x power 5 by 5. This pattern continues. Okay, and this implies log of 1 minus x divided by x will be minus of 1 plus x by 2 plus x square by 3 plus x power 4 by 4. Keep going. Okay, when we take limit x approaches 0, log of 1 minus x by x, the first term alone left, all other terms become 0. Okay, this application of log of 1 plus x. Just by replacing x by minus x, we can get the result. We can get the result. Okay, and if we take x equal to 0, x equal to 0, this is the value. X equal to 1, 1 minus 1, log 0 not defined, log 0 not defined. So log 0 not defined means x equal to 1, 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. The minus of 1 plus 1 by 2, 1 by 3 is not defined. But without minus, no, we can try to get the value by applying some grouping method, combining log of 1 plus x and log of 1 minus x. That area is not required in learning limits and continuity. Now we are concentrating what are the infinite series available, how to use the infinite series in finding a limit. Okay, this is third one, and we'll continue. The fourth one, the infinite series form of a power x. Infinite series form of a power x. Remember student, this a power x, or in general case, a function, any function, let it be f of x, can be converted as an exponential form. What is the exponential form of f of x? If we use base e power ln f of x, correct? E power ln f of x is f of x. So e and ln balance each other, because e power x is an inverse of ln x, or ln x is the inverse of e power x. E power x and ln x are inverse to each other, inverse to each other. So this is very, very important result. The conversion was very, very important. F of x equal to e power ln of f of x. We apply this, we can write a power x e power ln a power x. Am I correct? Then if we apply a little bit in the logarithmic law, e power, the x power, applying power rule on the exponent, it will be x ln a power x as an exponential function. This is also exponential function, but exponential function basis other than e. Actually, what is e? E irrational number. What is the value of e? 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial. Keep continue an infinite number of terms. So this is an irrational number. Irrational number. Okay, a power x equal to e power x ln a is irrational number. Now, and we can take a power x in the form of exponential function e power x ln a. Use the expansion of exponential function. What is the first term of exponential function? 1. Then x by 1 factorial. In the place of x, the whole thing should be taken. X ln a by factorial 1. Then x ln a the whole square by 2 factorial. Then x ln a the whole cube by 3 factorial. X ln a whole power 4 by 4 factorial. Keep going. So this is expansion of a power x. And if you want the expansion of 2 power x, 1 plus x log 2, that is ln 2 by 1 factorial, x into ln 2 whole square by 2 factorial. So you should apply the same pattern. Dear student, If we reorganize the terms, if we reorganize the term a power x minus 1, then from the rest of the group, x can be taken common factor. So divided by x. What is the first term? Ln a. Next term, x ln a the whole square by 2 factorial plus x square ln a the whole cube by 3 factorial. This pattern continues. We take the limit as x approaches 0. Limit x approaches 0. A power x minus 1 by x. The one and only one term ln a alone left. And the other terms 0. So this is a derivation of the fundamental result. And limit of a power x minus 1 by x is equal to ln a. Let's copy it. Still we have to discuss now and many more infinite series. And so far we have discussed the 3 infinite series. Now fourth one. Let me check the number. Number is not that much. Number 4 over is fifth one. Remember student, we come now. We are coming to trigonometric infinite series, and sin x as an infinite series, and x minus x cube by 3 factorial and plus x power 5 by 5 factorial minus x power 7 by 7 factorial. Keep going. Look at the terms. Sine mean the exponents are all number 1, 3, 5, 7. The same exponent in the factorial form in the denominator. And one more thing, and we have to notice, and the connectors not a positive symbol, alternately positive, negative, positive, negative, plus minus, plus minus, plus minus. So make note of it. And from this we can understand sine of minus x equal to minus sine x. If we replace by x by minus cx, every term negative, so negative, this negative positive, this negative. Then if we take minus common, it will be minus sine x. So sine of minus x equal to minus sine x. So many things can be understood easily with the help of infinite series form. Okay, this is log x, will not log x, is sin x. The other one, and cos x as an infinite series. The left of term will come 1 minus x square by 2 factorial and plus x power 4 by 4 factorial minus x power 6 by 6 factorial, and keep going. If we take all even number, 1 is nothing but x power 0. X power 0 by 0 factorial. Very important. Remember student, 0 factorial is 1. 0 factorial 1. 1 means factorial means just arrangement. So here nil arrangement, and 0 arrangement means that also one way. 0 arrangement, leaving the system as it is without doing any arrangement is nothing but 0 factorial. So 0 factorial equal to 1. So sine and cos. And one important things we have to remember, yes, we are learning and for competitive examination, so we have to elaborate our area and we have to expand our domain to understand and to learn everything. So in the combining from 5 comma 6, you can write then e power ix is a complex number, In e power x, you have to replace every x by ix. What the first term of e power x? 1 only. Then and plus ix by 1 factorial plus ix the whole square by 2 factorial plus ix the whole cube by 3 factorial plus ix the whole power 4 by 4 factorial. Keep going. Remember student, I equal to root of minus 1 iota, non-existing number. Iota means non-existing, imaginary. Now this complex number can be written in the standard form. What is the standard form of complex number? Real part and plus imaginary part. So real part, so 1 plus ix by 1 factorial. I square is minus x square by 2 factorial and I cube minus I x cube by 3 factorial, I power 4 plus 1 x power 4 by 4 factorial, then again I return I x power 5 by 5 factorial. Keep going. So here we can show the separation. Real part, the term independent of I, 1 minus x square by 2 factorial and plus x power 4 by 4 factorial minus one group. You can separate the group, okay, and plus I into what are the term in term of I? X by 1 factorial, x alone, minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial. Keep going. So remember student, and the real part of e power ix cos x, imaginary part of e power ix sin x. So this can be written e power ix is nothing but and cos x plus I sin x. This result familiarly known as Euler's formula. What is the name of the result? Euler's formula or Euler's formula. Euler's formula or Euler's formula. Then if we replace ix by minus ix, and what will come? E power okay, e power minus ix and cos x minus I sin x. This is nothing but conjugate of e power ix. So e power minus ix is conjugate of e power ix. From this, from these two equations, we can write cos x e power ix plus e power minus ix by 2 and sin x e power ix minus e power minus ix by 2i by 2i. So this is e power ix, e power minus ix. So this will come now in complex number. This application of the infinite series e power ix and e power minus ix. So the combination is nothing but Euler formula. With the help of Euler formula, we can solve many and problems from the and chapter complex number in easy manner. Okay, so dear student, so let us wind up today's session now.